Assalamu alaikum warahmatullah. Bismillahirrahmanirrahim. Today I select the title of my video is about the product of the two even and odd function. So in the last lecture I was explained about why the identity permutation is an even permutation, and I was also explained that what does we mean by the even and odd permutation. And first of all, I once again recall the definition of both even and odd permutation, that a permutation alpha is said to be an even permutation if it can be expressed as the product of even number of transposition. It means to say that if any permutation can be written as the product of the transposition and the number of the transposition are even in number, then we can say that the given permutation is said to be an even permutation. And similarly, a permutation alpha is said to be an odd permutation if it can be expressed as the odd number of transposition. Mean to say that if alpha is permutation and we can be express it into the product of transposition, but number of transposition in the product are odd in number, then we can say that the permutation is odd in odd permutation. So this is the basic difference between the even and odd permutation. Is just if the number of transposition in the product are even, then the permutation is an even, and if the number of the transposition in the product is odd, then permutation is said to be the odd permutation. Now I will explain about if we have to given two permutation and both are even, so what about the product? And if we have given the two permutation and both are odd, so what about the product? Is the product of two even permutation is always an even permutation, or is the product of the two odd permutation is always odd permutation, or the product of the even is maybe an odd? So the question is, theorem is the product of two even permutation. Product of the even permutation is an even permutation. So our question is the product of the two even permutation is an even permutation, and in the second one lecture is the product of the two odd permutation is also an odd permutation, and the third one is if the one permutation is even and other one is odd, then the product of them is an odd permutation. If the one is even, other is odd, then answer is odd. Both are even, then answer is even, and both are odd, then again answer is even. So I can prove this quite easily as well. Consider, say, alpha 1 and alpha 2 be two permutation. Suppose if we have a two permutation, that is alpha 1 and alpha 2, and assume that M1 and M2 be the number of transpositions in the product of alpha 1 and alpha 2. Because we know that a permutation is said to be an even if there are the even number of transposition in the product of permutation. If alpha 1 is even, it means there are the even number of transposition in their product, and I assume that there are m1 number of the transposition in product of permutation alpha 1, and similarly alpha 2 is an even permutation. It means there are the even number of transposition in the product of permutation alpha 2. That is, I said that, I assume that m1 and m2 are the number of the transposition in product of alpha 1 and alpha 2. It means alpha 1 has m1 number of transposition in the product, and alpha 2 has m2 number of transposition in their product. So now we have to show that alpha 1 product alpha 2 is an even permutation. But our aim is to show that the product of these two permutation alpha 1 and alpha 2 is an even permutation. And for this we must be sure that, because permutation is said to be even if there are the even number of transposition in the product. If we have to show that product of alpha 1 and alpha 2 is an even permutation, so for this we must have to show that the product alpha 1 and alpha 2 should have the even number of transposition. If there are the even number of transposition in the product of alpha 1 and alpha 2, so it means to say that then alpha 1 and alpha 2 is become the even permutation. So we consider the number of transposition in product alpha 1 alpha 2 as, that is m1 plus m2 minus of 2. This is the same as we have found that alpha 1 is an even permutation, so it has m1 number of transposition in the product, and alpha 2 is an even permutation and m2 number of transposition in the product. In the same sense, if alpha 1 and alpha 2 is a permutation, which is the product of alpha 1 and alpha 2, so this should have the number of transposition is the sum of m1 plus m2, is the number of transposition in alpha 1 and the number of transposition in alpha 2, which is m1 and m2. The product alpha 1 and alpha 2 contain the number of transposition as the sum of m1 plus m2 and minus of 2k, where 2k is a number which is always adjustable after the simplification for the number of the transposition in the product alpha 1 and alpha 2. But remember that with k may be a 0 or k is any natural number. K is any number which is maybe a 0 and a natural number, and this k is always used, or 2k is always used for the simplification for to adjustable the number of transposition in product alpha 1 and alpha 2. That is, I will explain it with suitable example. Now we can say that so alpha 1 product alpha 2 has m1 plus m2 minus 2k transposition. That is, alpha 1 product alpha 2 has m1 plus m2 minus 2k transposition, and this is implies is m1 and m2 both are even. That is, alpha 1 has m1 permutation, alpha 2 is m2 permutation, and m1 and m2 both are even, and the sum of the two even numbers is always even. 2k is always an even number. It means to say that m1 plus m2 is even and 2k is even, so the difference of two even number is always even. It means m1 plus m2 minus 2k is even number. if m1 plus m2 minus 2k is even number, but this 1 is the number of transposition in the product alpha 1 alpha 2. If this is an even, it means alpha 1 product alpha 2 is become an even permutation, as m1 and m2 are even permutation. So this is implies m1 plus m2 and 2k are even number, as the m1 and m2 we can say that where m1 and m2 are the two even number, that is m1 is the number of transposition, m1 is the number of transposition and m2 is the number of transposition. Both of them is even. If they are even and their sum is even and 2k is also even, and therefore we can say that m1 plus m2 minus 2k is also an even. Also an even number where k equal to 0 or any natural number, which is adjustable for the suitable simplification for this as well. It means to say that therefore alpha 1 product alpha 2 has the even number of transposition. Alpha 1 product alpha 2 has the even number of transposition in the product. So alpha 1 product alpha 2 is an even permutation. Therefore we can say that the product of two even permutation is an even permutation. I just give an example for this, that is, if we have the two permutation, that is alpha 1, 1 to 3, say 1 is made on 2 is made on 3 and 3 is made on 1. So in alpha 2, so 1, 2, 3, say 1 is made on 3, say 2 is made on 1 and 3 is made on 2. And now we can see that how these two are even permutation. We can write this as the product of transposition as, since 1 is made on 2 and 2 is made on 3 and 3 is made on 1, so this can be write as 1 into 2 and 1 into 3 is a number of the transposition. In the product of this permutation is 2, which is even number, therefore it is guaranteed that this alpha 1 is an even permutation, because alpha 1 has the 2 transposition in product, therefore alpha 1 is an even permutation. Similarly, I consider alpha 2, and if I write this, that is 1 is made on 3, 3 is made on 2 and 2 is made on 1, so this is closed and this can write 1 into 3 and 1 into 2, and there are the 2 number of transposition in the product of alpha 2, so alpha 1 and alpha 2 are the even permutation. This one is the even and this one is also even because it has 2 transposition is even and it has 2 transposition. So alpha 1 product alpha 2, 1 to 3, 2 3 1, 1 to 3 and 3 1 2. As we know that how can we find the product of the transposition? We have already discussed in some previous lecture that the product of the permutation can be found as, that is, write the first permutation same as well, that is 1 to 3 and 2 3 1, and also write the range of the first permutation is the domain of the second permutation. Firstly, writing the first permutation is the same as well, and then write the range of the first permutation in the domain of the second. And now adjusting the images from this permutation, that is 2 is mapped on 1, 3 is mapped on 2 and 1 is mapped on 3. And now taking the domain of the first permutation in the range of the second permutation. Domain of the first in range of the second, because these two terms are always same and these terms are always neglected, and therefore always taking that is 1, 2, 3. Domain of the first in range of the second. This one is an identity permutation. Identity permutation, which is an even permutation. Even permutation. And if I adjust the formula, that is, as alpha 1 has 2 transposition and alpha 2 has 2 transposition, it means we can say that alpha 1 has m1 is equal to 2 transposition, alpha 2 has m2 is equal to 2 transposition. Therefore, alpha 1 product alpha 2, that is m1 plus m2 minus 2k, that is 2 plus 2 minus of 2k, that is 4 minus of 2k. So what is k adjustable? Here k equal to 0 is adjustable, because I was said that 2k is a number which is always adjustable for the complete simplification for the number of the transposition in the product of transposition. A permutation that is m1 plus m2 is 4 and minus of 2 and k. So what is k is adjustable, because alpha 1 plus alpha 2 plus alpha 2 has the number of transposition. Alpha 1 plus alpha 2 has a number of transposition. What? It means k is not 0 adjustable, but k is 2 adjustable. K is adjustable as 2, because alpha 1 product alpha 2 has the number of transposition is 0 number of transposition. We can say that alpha 1 product alpha 2 is m1 plus m2 minus 2k, and k is a number which is adjustable for the number of transposition alpha 1. So we can say that alpha 1 has 2 transposition and alpha 2 has 2 transposition minus of 2k, and k is adjustable as 2. When k is adjustable as 2, then result equal to 0. It means 0 number of transposition in the product of the even permutation. So we can also get the more information of this theorem by regarding this example, and I hope that every one of you will understand this theorem quite easily, and inshallah in the next lecture I will deliver about the product of two odd permutation. Thanks a lot.